All right, so in example 2, we're going to again talk about how we can interpret confidence intervals, and then we're going to use this confidence interval to answer some other questions. So this is another type of common problem that you're going to see as we go through this section. So a random sample of likely voters showed that 49% plan to support Measure X. The margin of error is 3 percentage points with a 90% confidence level. All right, so report the 90% confidence interval of voters who plan to support Measure X. So our p hat is our sample proportion. So that is our 49%, and we change 49% to a decimal, 0.49. M is our margin of error. We're told it is 3 percentage points, so 3% is 0.03. Our confidence level, we're told, is 90%, and what we are looking for, we again are looking for the confidence interval. And our confidence interval is found by taking p hat plus or minus m. All right, so now we're going to state and interpret our confidence interval. All right, so to state our confidence interval, right, we're going to take p hat plus or minus m. So 0.49 plus or minus our 3% or 0.03. Again, we subtract it first. 0.49 minus 0.03, 0.49 plus 0.03. That's going to give us 0.46 to 0.52. All right, so our interpretations. Right, how would we interpret this interval? Again, we start with our confidence level. So we are 90% confident that the proportion of voters who will support Measure X is between 46% and 52%. So our interpretation, again, we start off with our confidence level, then we talk about whatever proportion we're looking at, right? And then we tell the range of percentages that we have. So we're 90% confident that the proportion of voters who will support Measure X is between 46% and 52%. Is there evidence that Measure X will fail? Well, here we're actually going to look at our interval. Our interval goes between 46% and 52%. In order for something to pass, it has to be more than half. It has to be more than 50%. Our interval drops below 50%. So we're going to say yes. There is evidence that Measure X we're going to say may fail, so we don't know if it will fail, but there is evidence that it may fail because there are values in our confidence interval that are below 50%. Right? So we can't say that it will or will not fail because our range of values goes both above and below 50%. Right? Suppose the survey was taken on the streets of Miami and the measure was a Florida statewide measure. Explain how that would affect your conclusion. Right? So we would say a sample from Miami does not represent the entire state of Florida. Therefore, the sample is biased. All right, so tying this into where we started at the beginning of the chapter, in order for samples to be unbiased, they need to be random and independent. This would not be an unbiased sample. This is looking at a particularly small group that's not necessarily representative of the entire population.